Welcome to Train Signal. You are watching Physical Network Connectivity. So obviously this lesson we're going to talk about physically connecting your vSphere hosts. And the idea of this lesson is it kind of sets up the next one. We're going to talk about a lot of different options, configurations, things that you can do. And the next lesson we're just going to spend a lot of time in the lab configuring a distributed switch again, going through a lot more configuration, going over again how to do the migration, and then looking at these options that we're going to talk about here in this lesson. So I just thought it was best to kind of split this out and figured we could focus on this before we move into the lab and just talk a little bit more about the theory and how you configure this. So with that, when we talk about physically connecting vSphere hosts, every environment's different. And there's really not a perfect answer. So everybody wants to see kind of reference architectures for the number of NICs and how you do traffic and how you do load balancing. And really, there's a lot of things that go into that. Installations differ due to requirements. You may have higher VM requirements or different storage requirements or other constraints such as your switches not supporting port channels, or you've only got 1 gig instead of 10 gig or something like that. And not everybody uses all the features. I mean, I love fault tolerance. It's the greatest feature. It's so cool. But since it's single vCPU, it's not used very often in production environments. So a lot of people don't do that. A lot of our customers use fiber channel storage. They don't do NAS. They don't do NFS. They don't do iSCSI. So it causes the configuration to change a bit. And one thing that I see as a consultant time again is it's common to see people overestimate their requirements. So I talk to people all the time, ask them what they need as far as throughput, for IOPS and all kind of stuff for network and disk, and they almost always overestimate. And when we go pull hard numbers, we see that really they don't need as much as they thought. But nobody's ever accused me of not wanting to overbuild an environment, so I'm all for it. But just keep that in mind, because it's common for me to see environments with 8, 10, or even 12 NICs plugged into every server, and often that's just a little bit crazy. There's a couple of good other good inputs on this subject by both Kendrick Coleman and Scott Lowe, both really smart guys, and they've both done some work. So Kendrick has a lot of great, as I just said, reference architecture type configurations for number of NICs, how to split traffic, what traffic can share, and Scott also has a great presentation on this. So honestly, I don't know if you need to worry about either of those for the exam. The exam is going to be heavy on configurations of the actual vSwitches, how we do traffic, how we split traffic. But for a lot of real world examples and good information, I check out Kendrick and Scott's blogs there. So why does it matter? Well, there are many different valid ways to configure physical networking. And often when I do what I call design workshops with customers, and we start talking and mapping out how they're going to do a new VMware environment, it's one area that gets a lot of discussion. And the problem is, if it's not right, it doesn't work as expected. Incorrect configurations can obviously cause problems. But, what problems? A lot of times it's not that it just doesn't work. It appears to work okay until you hit high load. Or you get errors on your switches and your network admin starts questioning about why you're seeing all these errors and MAC flapping issues and things like that on the switches. You'll see odd VM connectivity. One common one is if your hash types are set wrong between your switches and your servers, you may be sitting on a workstation and can ping a VM. Your buddy across the hall on the same network from his workstation cannot ping that VM. So you'll find that you get odd connectivity issues. You'll get overloaded and underloaded network cards. Very, very common. And less than optimal, as I call it, failover between your NICs and your interfaces. It can vary from, hey, that's kind of odd, to just flat out not working. And odd network configuration problems can really make you scratch your head. You'll pull up performance charts and see NIC 1 overloaded and 2 and 3 idle. Or again, failover doesn't work as expected. Or you can ping something, but again, a buddy down the hall cannot. So it's important to make sure we get this right. So a common question that I get, again, when doing these workshops is, how many NICs? How many NICs do I need to order for each of my servers? And it depends on a lot of things. My favorite answer as a consultant is it depends. It's make sure that I'm both right and hopefully not wrong. But it's common to see 6 or 8 1 gigabit NICs. I've seen up to 12. I used to work for a large financial institution, and we had 10 network cables plus at least 2 fiber channel cables plugged into every server. Utilizing FT or IP storage adds additional requirements, so both of them really want dedicated NICs. So you take off what you would normally do and then add a couple more for those. Recommended to have 6 NICs for fiber channel, 8 NICs for IP storage solutions. That's just a quick and dirty, and that also considers 1 gig Ethernet, not 10 gig. You can consolidate more with 10 gig. But I don't know if I'd call that a recommendation or just what I see as a very common setup. Commonly see extra NICs as a safety blanket. Like I said, people overestimate requirements. I've seen people do 6 and 8 NICs for balancing VM traffic out of their hosts and never go above 2. I've actually seen that more often times than I can probably count. So people see it as safety blankets, and you know what? If they want to buy the network ports and the cables and the NICs and the servers and pay for all that, you know what? That's up to them. And as somebody who sells network switches and cables and adapters and servers, that's fine with me. But often I try to pare it down just to make it a little bit more manageable and not to waste money. But again, some people just want to expect that, maybe if they grow, whatever, but they overbuild. Then the bigger hammer is 10 gig. Utilizing 10 gig greatly reduces NIC requirements. A lot of times we'll see servers or blades with just 2 NICs in them. Some platforms, like I'm a big fan of Cisco UCS, you can actually carve these up into virtual NICs, so I can take a 10 gig port and slice and dice it and give 1 gig to vMotion, 1 gig to FT, 4 gig to VM traffic, whatever we want to do, and really make better use of than just a flat out 10 gig pipe. But you see some interesting things with newer versions of vSphere. If they see a 10 gig connection, they'll use up to 8 gig of it for vMotion. And so we actually do some QoS to kind of push that down a little bit and make sure vMotion doesn't cause IO starvation or something like that if you're using NFS or iSCSI. We do that one of 2 ways, NIOC, Network I/O control, which we'll talk about in the next lesson, or another method for traffic shaping, such as what Cisco UCS does within what it calls its fabric interconnects. And this is one reason we're starting seeing more use out of Enterprise Plus licensing. So, you get NIOC, Network I/O control, and SIOC, Storage I/O control, in the highest level of licensing, and we're starting to see more people take advantage of this, especially as they go 10 gig. So here's a quick example of a system with 8 NICs. Basically, we have vMotion, and we have our 3 vSwitches here. This is sharing vMotion and management. So a vMotion VLAN, management VLAN, call these a port group if you want. And we're using an onboard NIC and an adapter NIC. One goes to one switch. If you can see that in blue is switch 1, green is switch 2. And one thing that I like to highlight is, if you have onboard NICs in a server and then you have add-on cards, split those. When you do redundant connections, make sure you split across those like I've done here. I don't want you to lose an onboard interface card or chip, or lose a PCIe add-on card, and it takes down an entire vSwitch or port group, and you really don't have the redundancy you thought. So that's why I mix those here. NFS, we want to make sure and dedicate that for dedicated NICs. Now, we can't load balance NFS, but I at least want them to be redundant in case one goes down. And again, one is onboard, one is the adapter, switch 1, switch 2. And then VM traffic, we just spread across 4, 2 to 1, 2 to the other, onboard, and the adapter. If you were to do FT, then you could share that with vMotion. That is one option. FT really wants a dedicated NIC, but people do that because vMotion's fairly bursty. It does stuff and then it slows down. Or you could add other NICs to dedicate to that, or you could pare down your VM traffic NICs if you didn't need this much. Physical switch configuration. The big key here is your physical switch config must match the vSwitch config. I mean, that's kind of straightforward, but it's worth repeating. So things like which VLANs am I trunking, what load balancing mechanism, any negotiation, things like that need to be the same on both sides. Tell your physical switches that the vSphere system is an end host, or what we call connected to an edge port and not another switch. Basically, if a switch is usually set up as default, when you plug a cable into it, spanning tree has to go through its listening and learning process. Depending on the version of spanning tree, that can be 50 seconds, 50 seconds. But we can say, look, Mr. Switch, I never plan to plug a switch into this port. It's going to be an end host. Even though I'm trunking VLANs, it's not another switch, so please speed that process up and immediately start passing traffic while you go through listening and learning to make sure that I didn't plug in a switch. So just be careful, because if you do this, it's going to make things great, because when a vSphere host comes up, there's no 50-second. If you disable and enable a NIC, it's not going to go through listening and learning. If you plug and unplug a cable, whatever. But if one day you do happen to plug a switch into it, there is an instant of time where you may have a loop in your network and you're going to have a really bad day. So most of us who've been in the networking, especially data center networking, hate spanning tree, but we have to deal with it. So keep that in mind, but we do recommend you set that for in-host or edge port mode. So here's a Nexus example. This is Cisco Nexus. Let's see here. So a couple of things here. In this example, I'm using LACP, and oddly enough, we can't really support LACP on 5.0, but I'm not really here to show you an overall switch config because you do not have access to switches in the lab for the exam. But I want to walk you through this just so you understand it. Basically, we're checking to confirm LACP is available. We do this with the show feature command on a Nexus. You have to turn things on. If it's not on, you need to enable it. Go into configuration mode, set a description. We set a channel group because we do a port channel. We'll talk about when you use port channels and when you do not here in a minute. We set the port to be switch port mode trunk, so we're going to trunk VLANs. We're going to tag them. Spanning tree port edge trunk. So this tells spanning tree that this is an edge device, not another switch. And then we can tell it that we want to trunk all VLANs, or if we're good little network admins, specify a list. What I want you to get out of this is edge trunk mode. So network options, in most cases you want all adapters on a vSwitch to be active, meaning if I got a port group like our VMs back there a minute ago and 4 NICs, I normally want them all to be active and load balance across them. But we may want to do some other things, maybe set active standby as a way to separate traffic, or we just don't want all NICs to be active for various reasons. There's actually some reasons with blade platforms, UCS and others, where we do set things active and standby because we want to send traffic out specific modules in blades. Outside the scope of this course, outside the scope of the exam. If you're interested in that, I discuss that pretty heavily in my UCS course when I talk about the networking. But we normally want these all to be active. So what about the other network options? And we'll come back to active standby and splitting traffic in a minute. But what about the other options? So there's network failover detection. This is one option in the switch that we'll see when we hit the big lab in the next lesson. But this detects the loss of a network connection. There's 2 ways to do this. One is link status. Does a NIC have a link light? Period. Does vSphere see a connection, see the NIC come up? It's simple, but it only detects the switch that you're connected to. It doesn't detect a failure upstream to the network. So, if I've got my host connected to a top-of-rack switch and a top-of-rack switch connected to an end-of-row switch or something like that, as long as the top-of-rack switch has a link light down to my host, I'm all good and happy. But if we lose the connection from the top-of-rack switch to the end-row switch, I'm not going to know about it. So we need to fix that. And so there's 2 ways to fix that. One is a lot of switches, such as Cisco, supports the concept of uplink groups and things where it says, look, I'm an uplink for a bunch of ports. If my uplink to the end-of-row switch goes down, shut these other ports going to the server down so they know about it. And you have to configure that on your switches, and it's different for different manufacturers and different versions of code. The other way we can do it from the vSphere side is what we call beacon probing. So with beacon probing, the NICs in your server send out test frames and then wait to see if they're received by the other NICs. It's a good way for detecting failures further up the network. So if I have a couple of NICs in my server, some going to one top-of-rack switch, some going to the other, and they both go to the end-of-row, if I send out frames off one set of NICs, it's going to go up to the top-of-rack, over to the end-of-row, back to the other top-of-rack, into my host, and I know that's a good path. But if something up level goes down, I'll know that it's not working. A couple of constraints or limits on this. You cannot use it with the IP hashing mechanism for load balancing. We'll talk about that, but basically you cannot do that. There's reasons for this, but it has to do with how the hashing works and the fact that we're not sure which NICs we're going to send or receive back in. And you need at least 3 PNICs. PNICs are physical NICs, so you need at least 3. And it's preferred to have an odd number if greater than 3. Why is that? Well, simply put, I need kind of a voting majority. If I have 2 NICs and I send a frame out, NIC 1 and NIC 2 doesn't get it, and I send a frame out NIC 2 and NIC 1 doesn't get it, which path is bad? Well, I don't know. They both are dead. But if I have 3 of them, NIC 1 sends it and 2 and 3 get it, 2 sends it, 1 sends it, but 2 doesn't get it, but 3 does. 3 sends it, 2 doesn't get it, but 1 does. Odds are it's NIC 2 that's having the issue, or the up level from that point, and vSphere will know to kill NIC 2 and mark it as dead. So you can't use it with IP hashing, and you need to have really an odd number of NICs. You can't do one. I know one's odd, so it's got to be 3 or more. And just as an aside, this was fairly popular with blades for a while because most blade chassis have an internal switch in them, and then they connect to, again, another top of rack into row switch. So it was a great way to check it, not just from the server or the blade to the internal switch, but beyond that as well. Again, you just have to have 3 or more NICs. Another one is notify switches. So when a link fails, do you want to notify the physical switches up level? Most of the time you want to say yes to this. So what happens is if I have 2 NICs, NIC 1 fails, and let's say I got a bunch of VMs, and half of them are load balancing across NIC 1 and half of them are load balancing across NIC 2. NIC 1 fails. Does the switch up level know that? Maybe not. So what happens when he's getting in frames from the network to send to the VMs that were on NIC 1? He sends them down that port, and they just kind of go nowhere. So for a while, we call that a black hole. Traffic goes in, we never see it again. So if you set notify switches to yes, when vSphere detects that NIC 1 fails, it does what we call gratuitous ARP for all the VMs that were on NIC 1 out the other surviving NICs. Basically, it sends out an ARP. It says, hey, the MAC addresses for these VMs now live on these other NICs, not on NIC 1. It's dead. And so the up-level switches know that, and they start sending all the traffic through the appropriate ports. If you set it to no, it doesn't do that, and traffic may black hole for a while until one of those VMs that was on port 1 actually sends traffic on its own. It goes out port 2. The switches above it go, what's weird? We're now seeing traffic for that VM on port 2. I guess he moved, and it'll update its MAC address table. Most of the time, you want to say this to yes. And here's the time you don't want to say yes. So don't set this if you're using Microsoft Network Load Balancing in unicast mode because of the way this works. It works fine in what we call multicast mode, but don't set it in unicast mode. The rest of the time, you will set this most likely to yes. Failback. So there's another option. We do this if we have NICs in active and standby. So let's say we've got 2 NICs set for active in a vSwitch, 2 NICs set for standby that sit there until they're used. Well, what happens if NIC 1 fails? It brings one of those out of standby, makes them active, takes NIC 1 and marks it dead. Well, you fix the cable on NIC 1 and he comes back up. Do you want NIC 1 to come back as active and take the one that was your standby and move back to standby? That's what this command does. So usually you'll set this to yes. Why? Because I want to know that NICs 1 and 2 on my server are active in all normal situations and 3 or 4 are standby. If I don't set to failback and I'm back there doing maintenance or cabling one day and I unplug a cable and I plug it back in and it flips those a little bit, it's not going to be in the expected configuration. It's going to work fine, but it's not going to be in the expected configuration. So most of the time people set this to yes. And for this to even do anything, you have to have a NIC in standby mode. If I got 4 NICs and they're all set to active, there is no failback. As soon as a NIC is dead, it marks it dead, and as soon as I fix it, it puts it back active. So this only works if you actually have NICs set for standby. Load balancing, oh, this is one of my favorite topics. I actually do a lot of the presentations on this at VMware user groups, and I talk about it at VMworld in some of my sessions, and it's one of these topics that causes a lot of confusion, mainly because, well, first of all, it's just confusing, and second, people use different terminologies, and third, they call it load balancing when it's not. And when you call something load balancing, I reasonably expect things on traffic across my NICs to be reasonably balanced, and often that's not the case. So this is a common point of confusion. First thing, there's no such thing in Ethernet as a load balancing mechanism that actually balances load. This is why I am on a one-man crusade to call it load distribution instead of load balancing. I'm not making much headway with that, but I'm going to stick to my guns, and I'm continuing to call it load distribution because it distributes load, not always evenly, but it does try to distribute load. So which method you choose depends on several elements. What kind of physical switches do you have and what are their capabilities? What kind of traffic is going to and from your VMs? Is it a bunch of clients to a server VM? Is it a lot of one-to-one communication? What is it? What's your VMware license level? Like all great things, you don't get everything in all licenses. All the greatest stuff is in Enterprise Plus. And then what's your vSwitch type, which kind of lives along with your license level. We'll talk about one that requires a distributed switch. So you got to have Enterprise Plus for that, and you got to have the distributed switch deployed for that. But those things together kind of start to dictate which load distribution method you should be using. And here's a screenshot. We're going to see this again in the lab, but here's where you set your load balancing, and that's also where you set the other commands we just talked about: network failover, notify switches, and failback. Anybody who's done anything with vSwitches recognizes that little block right there. So let's understand the problem real quick. I wouldn't be surprised for you to get questions on this in the exam. So of all the stuff I'm talking about in this lesson, probably this and maybe how to segment and separate traffic between NICs, we'll talk about in a little bit, are the big ones. So most protocols are not built for multipathing. That's just an Ethernet thing. They just weren't made for it. And switches don't like it when a MAC appears on multiple ports. So if I got a VM and I got a vSphere server with 8 NICs in it plugged into some switches, those switches often don't like it when that VM's source MAC address appears on port 1, then port 4, then port 2, then port 6, then port 3, then port 8, then port 1. It thinks something is going wrong. And often it'll think there's some sort of a network loop. It doesn't detect the loop because spanning tree does that, but it'll start throwing like MAC flapping or other errors in your log. So we have to, first of all, figure out if we want to load distribute like that, and second of all, we got to make sure the switch knows what we're doing so it doesn't think we're crazy. So we got to make sure we match these things correctly. Both sides have to agree, and that's really the whole thing about this, is you've got to make sure these things agree. So yes, I said load distribution. I've already given you my spiel on load balancing. It's wrong. It's not balanced. And the reason is very simple. We use a set of algorithms, and they're really just statistical algorithms. Basically, I give it input, the system hashes stuff, and it spits out a number. So we'll talk about this in a minute, but the bottom line is this. You'll hear me talk about conversations. Conversation is just a network connection between one system and another system. A VM to another VM, a VM to a physical host, whatever. At the end of the day, with all the current load balancing mechanisms, if I have one system talking to another system, you'll never get more than 1 NIC's worth of throughput. So if you've got 12 1 gig NICs in your server, all active in a port group, and you have one VM talking to a physical host on the network, don't call me and wonder why you're not getting more than 1 gigabit throughput. It's not going to happen. And the reason for that is fairly simple. There are some kind of non-standard hashing schemes that will let you do this, but no warranties expressed or implied, and they're not usually supported by most of the major vendors. But the reason is you can only hash things on certain values. You can hash them based on MAC addresses, IP addresses, ports, and like protocol type. Now, if I make an HTTP connection to another server on port 80, through the entire life of that connection, not one of those things changes. The source and destination IP don't change. The source destination port don't change. The protocol doesn't change. Nothing else changes. MAC addresses don't change. So when I feed things in, like if we do IP-based hashing, which hashes based on source and destination IP, you take the source IP, the destination IP, feed it into an algorithm, and say, okay, feed it into this algorithm, run some math, and tell me which of these 12 NICs it's going to hash over. It'll say, well, NIC 4. And no matter how many times I run the same source and destination IP pair through there, it always says NIC 4. So at no point are you going to get NICs 4, 5, 6, and 7 to hash across all those. It just doesn't work that way. So if you want to know how you get more than 1 gig of throughput between 2 single hosts using load distribution, the answer is really simple. You buy 10 gig cards and 10 gig switches, and that's how you do it. The only other way to do it is if you have a protocol built for multipathing, such as iSCSI. With iSCSI, we can bond multiple 1 gig NICs together, but it is aware of that. It was built to do this. The rest of your normal protocols are not. So, now that you've heard my spiel, my warning, and my, the kind of monologue that I do a lot of times, let's talk about the different teaming types. So the first one is called virtual port ID. It's the default, and it's the default for a reason. The next one is MAC hashing, which is very similar to virtual port ID. Then we have IP hashing, which is what most people think they want. And then we have load-based teaming, which I love, but requires the distributed switch. So let's walk through these. The key here I want you to get is to understand the difference in these and understand the requirements for what it takes to use each of these. So virtual port ID, why is it the default? Well, it's the default because it works everywhere. I can have 8 NICs in my server, 8 switches from 8 different vendors, if there are 8 different switch vendors, plugging one NIC into each different switch and all the switches connected together, turn on virtual port ID hashing, and it'll just work. You don't need intelligent switches. You can go buy the cheapest netgears on the planet at Best Buy, plug them together, and this will work. That's why it's the default, because it keeps you from calling VMware tech support. So, why does it work and why doesn't everyone use it? Well, it's really simple. In the simplest form, what it does is that as the VMs come up, and VM kernels count, by the way, since VM kernels are on the network and have a MAC address, they count kind of like a VM. But basically, the first VM or VM kernel that comes up gets hashed to NIC 1. The second one gets hashed to NIC 2, third one to 3, fourth one to 4th, on through. Once you run out of NICs, it starts back over at 1. If a VM has 5 NICs in it, they all get hashed over the same physical NIC, because it is doing it based on the virtual port ID, which a VM has one virtual port ID. So, it's quick, it's dirty, it usually works, but it doesn't work well. What happens if you have 4 NICs in your server, and let's say you have 5 VMs. First VM goes to NIC 1, second 2, 3, 4, and then VM 5 goes to NIC 1. And what if your first VM and your 5th VM are your most network intensive VMs, and they're killing that first NIC and the other ones are doing idle? What do you do about it? You don't do anything about it. You rolled the dice and you lost, and that's just too bad. You don't have a way to do this. The only thing you could do is vMotion some VMs around and kind of rehash a few things. And that's it. There's no control. It just works. And when it works well, it works well. When it doesn't, too bad. Just not your day. So that's the problem with this. It's very basic, simple load distribution, but it's the default because it works. So, if in doubt, try this, see if your stuff gets fixed, and then go from there. MAC hashing is really simple to virtual port ID. Honestly, the only difference is that, like I said, each VM gets a single virtual port ID, so if it has 5 virtual NICs, they still hash over the same physical NIC. This is different in that each virtual NIC counts as a different hash type. So, if a VM number 1 has 3 NICs, NIC 1 will go to the first NIC, virtual NIC 2 goes over the second physical NIC, virtual NIC 3 goes over the third physical NIC, and then it moves to the next VM. So, I actually like this a little better. I mean, I guess I like it better. I mean, it's almost the same. It just depends on the luck of the draw if this works out better for you than virtual port ID. The nice thing is, it's the same requirements as virtual port ID. Any switches work. You don't need to do any real configuration on the switches. No port channels. Do not use port channels with virtual port ID or MAC hashing. Just set them up as standard edge ports, trunk them, and that's it. And it works everywhere. But again, it's basic round-robin distribution and nothing more than that. So, know the difference between those two. One of them hashes each VM to a different NIC. The other one hashes each virtual NIC from VMs to a different physical NIC. Neither of them require any special configuration on the switches. And then there's IP hashing, which is what people think they want. The big issue here is it requires a port channel on the switch. That may be a problem for you, and here's why. Let's say I've got let's do something simple. I got a vSphere host with two 10 gig NICs. At the top of my rack, I've got 2 10 gig switches that I bought on sale from somewhere. Port 1 on the server goes to the first switch. Port 2 goes to the second switch. Can I create a port channel across those 2 switches to combine those 2 NICs? Well, the answer is maybe. Maybe because it depends on your vendor. I can't say yes or no. Cisco, I speak in Cisco terms, my apologies, but Cisco 6500s have a concept called VSS. That's normally on the Cisco 6500 Catalyst with the newer SOUPs, like SOUP 720 and newer. You can connect those two 6500s and say I want to treat it almost as a single switch, and so I can have one NIC going to the one of those 6500s, the other NIC going to the other 6500. They'll talk to each other, and I can create a port channel for that. The newer Cisco Nexus switches, the 5Ks, the 7Ks, have what we call VPC, a virtual port channel. Very similar concept to VSS. It's a different technical implementation and all that, but in the end, I can connect one NIC to a Nexus 5K here, the other NIC to another Nexus 5K there, connect the Nexus 5Ks together and just say, look, you guys are a pair, and create port channels. You can also do it with switch stacks. I do a lot of these little switch stacks for people with Cisco and small data centers, like a stack of 3750 switches. So it's a couple of one-use switches, but they have a backplane that links them together, and they operate like one larger switch. So I can plug NICs into one switch, NICs into another switch in the stack, and create a port channel. So it would be simple if you connected all your NICs to a single switch, but then you're not redundant. So you've got to make sure and do that. It's the best hashing mechanism for client server. The reason being is, let's talk about that concept of conversations again. If you and I are talking, we are having a single conversation. We can only hash that across one single NIC. No matter if we're using virtual port ID, MAC hashing, or IP hashing, it's my IP to your IP, my MAC to your MAC, my virtual port ID to whatever. It is basically the same thing. But if I'm a server and I've got 20 people out there talking to me, I have 20 different conversations. With MAC hashing, it's done on source MAC address. Well, the source for me is always the same. It's always my MAC address. The virtual port ID hashing is always the same. It's my virtual port ID. But IP hashing is different because it uses both the source and destination IP. The source, me, and the destination, the person I'm talking to, changes with each conversation. So 20 conversations should theoretically spread across all my NICs fairly evenly. Again, it's a hashing algorithm. You may end up with 4 NICs and 20 conversations with 5 on one, 3 on the next, 8 on this one. Let's see, 5, 3, that's 8, 8, 16, and 4 on the last one. Doesn't mean it's going to be 5, 5, 5, and 5. It just means it's going to try to balance that across. Not going to be perfect, like I said, but it'll get you there. But if some of your conversations are throwing more traffic than others, you don't get to pick where these things go. You may still roll the dice and lose and end up with your heaviest communications between servers on the same NICs. But it gives you a bit more granularity. And remember, it's all about those conversations, connections from the server to the client. We can spread those across. And again, no single conversation uses more than one NIC's throughput. And then there's load-based teaming. It's my favorite. It's my favorite if you have Enterprise Plus and you'd use a distributed switch. It's not perfect by any stretch, but it's the only proactive load distribution method. It's called route based on physical NIC load in the UI, and we'll see that in the next lesson. But it's also called load-based teaming, or LBT. I don't know why VMware gives it 2 names, but that's what they do. It's the only utilization-aware option. It requires Enterprise Plus and the VDS. It does not require port channels or anything like that. It has the same requirements as virtual port ID hashing because technically that's what it's doing. But it's really cool because the vSphere host monitors all my NICs. If I have 4 NICs in this switch, it monitors them. If one of them starts doing higher than 75% load for 30 seconds, it moves the MAC addresses to less utilized NICs. So if I have NICs 1, 2, 3, 4, NIC 1 is at 90% utilization for longer than 30 seconds and it has like 8 VMs hashed across it, it'll pick a couple of those VM MAC addresses and move them to one of the less utilized NICs and try to balance the load. It's not going to be perfect because, again, we can't let a VM use more than one NIC's worth of throughput, so that's as granular as we can get as a VM to a NIC, but it tries to be proactive about it. Initial placement is the same as virtual port ID, meaning when the vSphere host boots up or you start up VMs, it initially hashes them like virtual port ID, so it basically goes round robin through the NICs, and then it starts looking at utilization. Requires no special switch config, same as virtual port ID or MAC hashing, so no port channels or no VSS, no VPC, none of that. It just works. I recommend to use LBT if it's available. The only exception is what I just talked about with IP hashing. If you have a server VM that needs to do a lot of traffic to a bunch of different clients, IP hashing is still your best bet. The problem with LBT is the most I can do for a single VM is 1 NIC's worth of throughput. So if I've got 50 clients talking to that one busy server, all that traffic is going to go across 1 NIC because it's virtual port ID hashing. So in that case, you may want to go do IP hashing. But again, I commonly see people overestimate their requirements, and once we look at it and see it, often they go to LBT. What about IP storage? So what do we do about hashing, load balancing, load distribute IP storage? Simple answer is you don't. There's no way to multipath NFS. I wish there was. I love NFS data stores for VMware. I love them because they're simple. NFS storage systems have gotten much more intelligent. They understand the concept of the files and the VMDKs on the data stores. I can mount an NFS data store from my Mac and pull files off of it if I need to. A lot of cool stuff, and now they support VAAI for offload. Downside is you can't load balance with them. There's just no way to do it like we can with iSCSI. So either you go 10 gig, or you have on your NAS NFS servers, you create multiple NFS IPs and you manually distribute data stores across them. So maybe you give it 4 IPs with 4 NICs or 8 NICs for redundancy, and you say, okay, data stores 1 and 2 are on the first IP, 3 and 4 on the second IP, 5 and 6 on the third one, 7 and 8 on the fourth one, and manually just try to, break the traffic up. But there's no way to give a vSphere host to a single data store more than 1 NIC's worth of throughput. Just not there yet. We need newer versions of NFS for that. iSCSI is a different animal. We're going to talk about that in a later lesson, and I'll actually show you this in the lab. It's one of the great things about iSCSI is that you can have 4 1 gig NICs and actually get 4 by 1 gig throughput on it. It works really well, and with 5.0 they've introduced or moved a lot of the configuration into the UI instead of doing it via CLI, so it's much easier to configure, and we're seeing a lot more people use it for that reason. Connectivity recommendations. So I've hit on some of these as we went through. If possible, use redundant NICs on different cards. So if you've got, again, onboard and expansion spread across. If traffic types will be mixed, look at the profile of the traffic. Bursty or sustained, high or low. So like a good one, common, like low traffic is management and bursty high traffic is vMotion. I have no problem putting those two on the same set of NICs. Even with vMotion is flat out, it's usually not a problem. But don't do like vMotion and I said you could do vMotion FT, which you can, but vMotion and IP storage, because while it starts at vMotion, it's going to kill your NFS or iSCSI connectivity. And don't do vMotion and VM traffic unless you have really low requirements for VM traffic, because you'll overload that. So just be careful what you mix. Never share with IP storage, like I just said. And FT really wants dedicated NICs. But you don't have to make them redundant. A lot of people don't want to throw 2 NICs at FT, so I just say 1. If the NIC goes down, you can redo FT and it'll figure out what it can talk to and what it can't, and move the secondary VM around. So it's not a dead requirement that you have to have redundant FT NICs. Management traffic is low. You can often share that. And traffic separation with the distributed switch. So we're going to see this more in the lab, but there's really 2 ways to separate traffic. And what I mean by this is I want to dedicate 2 NICs for NFS and 4 NICs for VM traffic. So I want to make sure those 2 NICs for NFS only get used by NFS, and the 4 only get used by VM traffic. And we saw this a little bit when we talked about the distributed switch. We'll see it more. But basically, when you deploy a distributed switch, you give it a set of NICs to use as uplinks for the server. We added those uplinks when we migrated the host in. You only get 1 set of uplinks per distributed switch. So what it normally means is all physical NICs out of the VDS need to trunk the same VLANs. There are some ways you can not do that, but it gets a little bit complicated. So I'm going to say you need to have them trunk all the same VLANs. So don't yell at me and say, well, it's not technically true. You're right, it's not. But I'm going to tell you for simplicity's sake that you should. But what if you want to separate traffic? You have 2 options. The first option is what VMware recommends that you do. They actually kind of requested that I switch my preference for one of my sessions at VMworld, because this is what they like to suggest. And I don't argue with it. It's personal preference. But on a port group by port group basis within the distributed switch, you can take those DV uplinks, those distributed switch uplinks, and say, okay, these are active, these are standby, these are unused. So let's say you had 6 NICs, NICs 1, 2, 3, 4, 5, 6. 1 through 4 you want to use for VM traffic, 5 and 6 for NFS. You'd go to the NFS port group, whatever port group you're plugging the VM kernel into, and you would set NICs 1, 2, 3, 4 to unused, and 5 and 6 to active. And then you'd go to the VM port groups and set 1, 2, 3, 4 as active, and 5 and 6 as unused. Now, knowing that, you could only trunk NFS through 5 and 6, and the VM VLANs through 1, 2, 3, 4. But that confuses some people. It can also break things like LACP, which is now supported in vSphere 5.1. Remember, the exam is on 5.0, so we act like LACP support does not exist yet. But if you're thinking about deploying this in your environment, keep that in mind. So you could do that. So the first option is active standby unused, and the second one is just multiple distributed switches. Yes, you can do that. Yes, a host can belong to multiple distributed switches at once. So you could have an NFS distributed switch with 2 NICs as uplinks, 5 and 6. And then you could have another distributed switch for VM traffic with uplinks 1, 2, 3, 4. I personally like the second method, mainly because if you get hit by a bus, I can come behind you, load up the vSphere client, and see that pretty apparently what you have done. If you do active standby unused, number one, document it, and number two, if you get hit by a bus, I'm still going to have to go behind you and make sure that what you did is right and figure out my active standby unused configurations. So I think the multiple VDS is simpler. A lot of my guys that I work with say, no, I want to do active standby unused. They're both technically correct. It's up to you, and we'll look at those in the lab. Like I said, I prefer single, except in cases where risk of configuration mistakes are a concern, because it's really easy to set the wrong NIC as active instead of unused, or standby instead of unused. And if you're in, say, a PCI compliant environment or something with DMZ networks on the same switch, I prefer separate distributed switches. So here's a quick and dirty diagram showing multiple distributed switches. So this is a host. It says vSphere host. One distributed switch for the DMZ, one distributed switch for prod. These are my two physical NICs I have for uplinks in this switch. These are my two physical NICs I have uplinks in this switch, and they connect to the appropriate networks. And here's kind of an uplink table. So if you do want to do active standby unused, you can say, okay, I've got, 8 NICs. For management, port group 1, and this gives you your teaming type for explicit and what type of failover you want to do. But basically I have 1 and 2 as active standby. And then I share that, if you notice, with FT, which you could either do with vMotion or FT, it's up to you, for FT with uplinks 1 and 2. So basically, as long as everybody's up and happy, NIC 1 carries management, NIC 2 carries FT, but if either of these fail, they'll share the same NIC, which is fine. I have 2 of them for vMotion because we can now do multi-NIC vMotion and do multipathing for vMotion and make it faster, so I've got NICs 3 and 4 for that. If one of them fails, it'll flip to the other. And then I've got iSCSI, dedicated NICs to iSCSI. We're doing multipathing, so when you do multipathing iSCSIs, we'll see in a later lesson, you cannot have standby or secondary NICs, so it's one-to-one mapping. And then for VM traffic, we use NICs 7 and 8, and I use load-based teaming. So this is one option for active standby unused, or you could split some of this out and have a distributed switch for iSCSI, distributed switch for vMotion, FT and management would share one, and you could have one for VMs. Again, it's personal preference. Play with it in your lab and see which one you like better. And this is suggested for a server with 8 NICs. Your mileage may vary if you've only got 6, or if you got 10, or you got 10 gig. Just adjust these. And again, as I talked about early in this lesson, Kendrick and Scott both have some examples. Here's an uplink table with a single VDS with 10 gig. So we say we only have 2 10 gig ports. Management, 1 and 2. vMotion is 2 and 1. And we have vMotion and FT sharing the same active NICs, mainly because it's 10 gig. So we've got capacity to do it. We put iSCSI as an offset, so we don't want iSCSI on the same active as FT and vMotion. And then VM, we use load-based teaming again for both 1 and 2. That way, if, say, iSCSI goes nuts on DV uplink 1, load-based teaming will move those VMs to uplink 2 and try to balance that. So it just depends how you want to do it, but again, this is an example with 2 10 gig ports. And that's it for the lesson. So what I want you to get out of this, I know I threw a lot at you, a lot of different hashing types. What I want you to get out of this, especially for the exam, on things that I consider to be testable, know the different load distribution configurations. In case you get a question like, look, server 1 is connected to this kind of switch, and it has this type of traffic, VM talking to a bunch of servers. Configure the load balancing so that each virtual NIC in the VM gets hashed to a different physical NIC. Well, that would be MAC hashing. If it said, set the load distribution so each VM gets hashed to a different physical NIC, that would be MAC hashing. So just know the differences and know why you do one thing against the other, and know what the requirements are, such as virtual port ID and MAC hashing do not require port channels. IP hashing does require a port channel. Load-based teaming does not, because it uses virtual port ID. It's just proactive about it, but it does require Enterprise Plus. So know those things. Have a good idea of what you could share with traffic, but the fact you can share management and vMotion is not one of those things that's written in stone. Some people like to split out management and share it with nothing, so I don't really consider that to be testable. The only way that's testable is if they give you an example and say, hey, configure the NICs on this server so that management and iSCSI share the same NICs, and VM traffic goes over these other NICs, know how to handle physical separation of traffic. And we're going to look at that again in the next lesson as we go through the lab and show you that as more of a tactical level actually in the distributed switch. But just keep an idea of how you would think about doing that, and just work through that process. So that's it for this lesson. In the next one, again, we're gonna jump in and really look at the distributed switch again. So I look forward to seeing you on that one.